All right, we're going to do another example here. Given an equation in standard form, how can we pull out all the things we need and graph this ellipse? So a couple of differences I want you to note right away is our larger number is underneath y instead of x. And that's going to cause, instead of our ellipse to be wider and shorter, instead it's going to be the longer, or the major axis is going to be up and down. But we'll get there in just a moment. So we could still easily pull out our center. It's going to be at -2, 5. And because in our Pythagorean identity that a squared is equal to b squared plus c squared, a has to be the largest. So since 49 is underneath the y squared, I'm going to make a equal to the square root of that, or 7. And b is going to be the minor axis, so it's the square root of 9, or 3. And if I go ahead and plug that into this here, I'd say 49 is equal to 9 plus c squared, and I would end up with c being the square root of 40, which is just 2 root 10. Now, how does that change things? If I were to graph this, I would go over 2 and up 5, and I'd put that as my center. Since I know that it's going to be taller instead of wider, then my foci are going to be c units away from the center, but they're going to be changing up and down. So -2 would always be the x-coordinate, but I'd be doing 5 plus or minus 2 root 10. That represents both of the foci. It's not a clean number. If it was a clean number, I'd want to see that, and that's what I'm going to do with the vertices. But I would be going up, which is something a little bit more than 6 and a little bit up and down a little bit more than 6. So I don't know how well that's going to come out here. Okay. If I want to find the vertices at the end of the major axis, which is what the book always gives you, I would go up and down 7. So I'd have -2 and then 5 plus 7, and I'd have -2 and 5 minus 7. So I'd have something like this and something like that. And then for the endpoints at the end of the minor axis, I'd be going 3 to the left and to the right. So if I was at -2, 5 and I went 3 to the right, I'd be at 1, 5. If I went 3 to the left, I'd be at -5, 5. So 1, 2, 3. 1, 2, 3. And then I just sketch in, see what my ellipse would look like. And that should be all the important points from that ellipse.